Yes,
Frank, is my screen visible?
yes, visible.
Okay, thank you. So, after one long month, we are finally back with the presentation in the source content team. And today I'm starting with a new topic that is a programming language. And we all know this language as Java. So, in the introduction part, we'll first see what exactly is Java and what was the main reason of inventing Java and who was the person who invented Java. So, Java was created by James Gosselin and his team at Sun's Microsystem in 1995. So, James Gosselin is also known as the father of the Java. And basically, Java was actually not a programming language when it was earlier introduced during the time when it was being created. It was actually a project that was made by James Gosselin and his friends. And later on, that particular project which James Gosselin and his friends made, that was later on turned into a programming language, which we now known as Java. So the language was initially developed as a part of a project to create a platform independent language for consumers electronics such as set-top boxes. The project initially called Oak was later renamed as Java after discovering that the name Oak was already in use. So this is also one of the fact that earlier, the same programming language which we know today as Java was known as Oak, but later on that was removed because it was being used by some other discovery and it was actually patented. That's why later on the name Oak was removed and Java was kept because James Gosselin used to drink coffee a lot. That's why he even introduced the symbol of coffee as the symbol of Java thereon. So, now let's move on to the overview section. So, what exactly Java means? So, Java is a versatile platform independent programming language known for its write once, run anywhere capabilities. It emphasizes object oriented principles, providing robust security, rich standard libraries, and built in multi threading support. Widely used in web, mobile, and enterprises applications. Java is favored for its simplicity, scalability, and strong community support. So, firstly, let us understand what exactly platform independent programming language means. So, like other programming language, Java is a platform independent programming language. That means that the program created in a particular system can be run anywhere on any particular system without any problem, which was a issue in some of the programming languages earlier that the particular programming system and a particular program that was developed used to run on that particular system only, and we need certain other sort of programming software to run that same program into some other system. So in this particular problem was actually removed in Java because the program which we used to write in Java can easily be run on any other programming languages and other platform even. So that was why it is a platform independent language. And moreover, Java used certain object-oriented programming principle that made it much easier to use. Moreover, there were several security features that were being provided. There are standard libraries, which we now known as the framework, which is being used to make this particular
Suresh,
language
wait a
so
minute.
much.
Guys, you ask your doubt
Okay.
after the session of Suresh. Like after the Suresh complete its over presentation, after that 5 minutes will be allocated and you ask doubt at that time. Suresh, continue.
Okay. So now this was the overall overview part that we have seen so far. Now let's move on to some interesting. The first interesting fact was that Java was initially called as Oak, which we discussed in the introduction part as well. And this particular feature in Java was actually, sorry, this particular name of Oak is a very funny concept that James Gosselin and his team named his project that they were creating during a research time. and they named as O. But later on, they thought that they will be introducing this particular project into the market. But later on, they came to know that this particular name was already patented. So thereon, they decided to change the name, and later they renamed Java as they were inspired by Java Coffee. Java mascot. The Java mascot is a cute a coffee cup inspired character named Duke, which was created by one of the original Java developer, Joe Palrang. So the mascot of the Java, that is the symbol that using to introduce and represent Java. So it is a cup in which there is a small leaf. So this particular mascot was actually developed by one of the friends of James Gosselin, that was Joe Palbrang, and he introduced this particular thing. And the third one is Java is everywhere. Now, what exactly Java is everywhere means? So, Java is actually being used over 3 billion devices worldwide, including computer systems, smartphones, game consoles, and even spacecraft. And this particular language is very, very easy to learn and understand and it is very simple. And moreover, we can perform any sort of task with the help of this language very easily. So, definitely we must learn this particular language if we get some sort of time. So now what are the key uses of Java? So Java is used as an off to build an enterprise application, Android development, web application, embedded systems, scientific and research applications. These are the certain key uses by which we can use Java. We can easily build an Android app using Java. Java Kotlin is being used over there. Web applications can be built using Java using the Spring framework and the Spring Boot concept. Moreover, several research application and scientific application can even be developed by the help of Java because it is having a very and moreover a very effective library which help us to create easy applications in a much easier fashion, and moreover the application created using Java are very effective. Now, what are the features of Java? So, because each and every programming language has certain sort of features, and similarly, Java is having certain features that make it very useful for an individual to learn this particular language. So, the first system is platform independent. That is, write once, run anywhere. That means that we need to write a program on a particular system, and we can run that same program on any system without any fault or any sort of mishappening. Moreover, the second point is that Java emphasizes an object-oriented concept, that is, it emphasizes principle, which is one of the key reason why Java is one of the successful language nowadays. Robust and security. Strong memory management and security features are there within the Java language, which makes it quite useful to the users who are using it. Moreover, multi-threading is being there used in Java that supports concurrent programming. A concurrent programming is a sort of programming in which one program executes after another program without any fault. And the fifth one is the high performance, that is through just-in-time compilation. That is the output that is produced using Java is very fast as it provides high performance like just-in-time compilation process. Now let's move on to the Java architecture. So now basically there are three types of Java architectures that we need to know. The first one is JRE, that is Java Runtime Environment, JVM, Java Virtual Machine, and JDK, that is Java Development Tool. Now, these three are the basic Java architectures that an individual must know. And moreover, the most useful Java architecture that we'll be seeing is that JVM and JDK, because JVM is a Java virtual machine which helps in which actually controls all the working process of Java program. And moreover, Java development kit help us to use various sort of libraries, frameworks that makes it quite useful for the user to learn it. Now, Java syntax and structure. So the basic structure of a Java program is class declaration, method, main method, and an example of a simple Java program. So, we'll be discussing about the entire structure and syntax of the Java along with the programming languages in the upcoming sessions as well. And there will be we'll be seeing how exactly we can write programs using Java. And when we'll continue this particular session of this programming language, that is Java, we'll be creating some sort of web applications as well by the help of the Java programming language. So that will help us to deeply understand this particular language in a much easier fashion. Now, what are data types and variables? Java actually has a certain sort of data types. That is, one is the primitive data type. That is integer, float, character, double, boolean, etc. are the some sort of data types that we'll encounter in later on when we'll study about these particular topics in detail in the upcoming weeks. Reference type objects are there. Variable declaration and initialization is another method that we can declare a method variable, and we can even initialize a variable by a particular value that can be used in the program later on. So these are the quite useful features that we get in Java. Now, operators in Java means Java has a variety of operators that we can use to perform various mathematical calculations. It includes arithmetic operators, relational operators, logical, bitwise operators that we'll be discussing in the upcoming weeks, because this particular presentation of today's is regarding the introductory part of the Java only. So we are not studying about a particular operators or variable data types in detail, but we'll be discussing it in the upcoming week as well. So every Saturday you need to stay tuned and you must attend the session so that you can learn about the same language in detail. Now, what are the control statements? So, control statements includes if statement, else statement, switch statement. These are the very useful statements that are very frequently used during programming purpose, where if a programmer is writing code for a particular program. Loop statements includes for loop, while loop, and do while loop. And most probably, the most important part of the loop is the for loop and the while loop, because these two loops are used most often during the programming purposes. Branching statements like continue and return are even comes under the conditional statements, control statements. And regarding the branching statements, I think break and return. These are the two most frequently used the branching statements that we'll be seeing in the programming concept. Now let's move on to the classes and objects. So what exactly class means and what exactly a class is. So a class is a blueprint or a template for creating object. It defines a data type by bundling data and methods that operates on the data into a single unit. So actually class is just like a blueprint or a template in which objects are being created. Like we create a class, and on the basis of the class we create the objects. That is as it is written over there, that by bundling the data and the methods that operates on the data into a single unit. That is, by the help of classes and object, we bundle the data and methods into a single unit. Whereas object is an instance of a class. When a class is defined, no memory is allocated until an object of the class is created. Now, both classes and objects have a relationship with each other, and that is when a class is defined, that particular class is not allocated any sort of memory. But until we create an object, once the object of the class is created, a separate memory is being allocated to a class where the entire content of the class is stored. So this is why classes and objects, these two are the one of the key concepts in Java, and we'll be seeing it in the upcoming as well. Now let's move on to the object-oriented programming in Java. So object-oriented programming is a programming paradigm based on the concept of objects which can contain data and code. Data in the form of fields, often known as attributes or properties, and code in the form of procedures, often known as methods. Java is fundamentally an object-oriented programming, and it incorporates the core principle of OOPs. So, well, as in the beginning, also during the introductory part, I mentioned that one of the key reasons why Java is very popular nowadays is the use of object-oriented programming. because object-oriented programming helps our user a lot during uh, any sort of application development or programming purposes. And that is why this particular concept of object-oriented programming is even followed in the programming languages like Java, because it is very useful for an individual. Now, in the object-oriented programming, let's move on to the first part that comes in the OOPS, that is encapsulation. So, encapsulation is a practice of wrapping the data, variables, and codes together into a single unit. In Java, encapsulation is implemented using access modifiers like public, private, protected to restrict access to the inner working of the class, exposing only what is necessary to method. So, what exactly encapsulation means? So encapsulation is actually a method in which different types of data are wrapped together. Now, wrapping is just a similar concept like we all know about aluminum foils. And in the aluminum foil, we actually place any sort of chapati or whatever the thing stuff we want to keep, and then we wrap that thing into a single unit. That is, there in that aluminum foil, we keep at least 2 to 3 chapatis, and then we wrap it. And for a user, it will seem to be a single unit, but within that particular wrapped aluminum foil, there will be several sort of things. So encapsulation is related to hiding and abstracting data related to the method, and encapsulation is actually implemented using methods like public, private, and protected, and to restrict access to inner working of a class. Now let's move on to this part. Actually, inheritance allows a new class, that is a subclass, to inherit the properties and behavior, that is fields and methods of an existing class, that is a superclass. This promotes code reusability and establish a natural hierarchy between classes. So, well, inheritance is like inheriting the property. And as you all can see, the definition says that when one subclass inherits the properties of the other superclass, this is known as inheritance. So, well, the easiest example to understand inheritance is like generally every family has a younger brother or sister who is actually working on some sort of companies, or who is in a government job. So every Indian parent says that you must actually acquire some of the properties of your brother, much more stronger and much more capable than you. Like you must think how, you must see how exactly he studies, what is his daily routine. You must follow that and inculcate that his or her activities in your lifestyle, so that you can even get success. Similarly, inheritance is the same, in which a subclass is inheriting the properties of some superclass, so that the entire code reusability can be used. Code reusability means once a code is being written, there is no need to rewrite the code again. This not only saves the time of the programmers, but also the memory, which is one of the key concepts of object-oriented programming. Now, the third one is the polymorphism. So, polymorphism allows object to be treated as an instance to their parents rather than their actual classes. The actually polymorphism is of two types: compiler time, that is compile time, that is method overloading multiple methods with the same name but different parameters within the same class. The second one is the runtime, that is method overriding. A subclass provides a specific implementation of a method that is already defined in its superclass. So, well, polymorphism, see, the definition over here is a complicated one, but to understand this particular part of OOPS, we can, when a subclass acquires the property of two or more superclasses, then we can say that polymorphism is a concept that is based on that. And moreover, polymorphism is actually of two types, that is compile time, that is method overloading, and the runtime, that is method overriding. And we'll be seeing the same method of polymorphism in the upcoming sessions as well. Now the fourth and the last one is abstraction. Abstractions involve hiding the complex implementation details of a system and exposing only the essential features. Java achieves abstractions through abstract classes, a class that cannot be instantiated and may contains abstract method. Methods without a body is an abstract method, and that's a class must implement. Whereas the second method by which we can implement abstraction is by interfaces. A contract that a class can implement interfaces can contain abstract methods that the implementing class must define. So now the easiest method to understand abstraction is like whenever we see a car, we actually see the outer part of the car. We are not seeing the how exactly the entire working mechanism of the car is being working, where exactly the engine is fitting, how exactly the AC vents are being fitted, how exactly the brake system works. Like we are only concerned with the physical facilities that are being provided in the car. We are not trying to think how exactly the inner things or within the car will be working. This is like abstraction, like involving only those information that is revealing only those information to the user that is useful to the user and hiding the rest other stuff that is being not essential to the user is known as abstraction. So now in the conclusion part of the object-oriented programming, we come to know that Java OOPS promotes code organization, reusability, and scalability, making it easier to manage large software projects by understanding and applying these concepts. Developers can build robust, maintainable applications that are easier to extend and modify. So, well, this was from all from my side related to the introductory part. Well, if you have any doubt, then you can definitely ask me.
Guys, if you have any doubt, then ask.
No, I don't have.
Okay.
Okay.
So give me a second to start my presentation.
Okay.
My screen is visible to all. Am I audible?
Yes, yes.
Okay. So, in my previous session, firstly, I will brief that when the source content is start. After that, firstly, I will cover the topic that is GitHub. I will cover in the span of 12 sessions, and I cover the basic portion of the GitHub, because basic thing of DevOps is GitHub, and Git is the main part where developers interact with their codes and update their codes. Okay, so if someone's have to work on project, then he or she must be on GitHub to collaborate for that project. Okay, so in previous 4 sessions, I'll start the Docker part, and in this session, I will summarize whatever I explain in those sessions also. But here I will take only 2 to 5 minutes per slide. If you go on my previous the videos are uploaded on YouTube. If you want to see the complete details of a particular presentation, because here I have covered in this presentation I have 45 slides, but if you go individual like Docker part 1, here only 10 to 5 slides, and there I will explain in detail much. Okay, so here I will just wake up I will just summarize, give a summary of concept whatever I tell previously. So just start. So introduction to Docker. So firstly, what is Docker? Docker is used to store a multiple services. Like if you are a developer and in your laptop you have in your laptop you want to run multiple web services. Like if you want to interact with the databases, if you want to interact with the APIs, and simultaneously these all processes are running. And like I am a developer, I have to deploy two apps. Then these two apps are deployed in a particular container, and these container provides the process that doesn't affect each other. Okay, so introduction to develop Docker. Some key features of Docker. With the help of Docker, we can simply launch your application inside a container. Containers is basically like a box where we deploy our application, and that box where inside the process are continuously in running phase, not in the static phase. Like the interaction between databases and the user interface front end is ongoing, and these process is working simultaneously, like working with backend code, and backend code interact with your database, then the backend code response, like browser response to client side. So these all processes are simultaneously. And if you have made like particular web services and microservices, so the container concept is must use. So with the help of Docker, we can simply launch your application inside the container. If you want to run multiple application run simultaneously, Docker is useful. I tell previously that if you want to run multiple application, then Docker container is a useful thing. Each container are based on a specific image. So what is image? Image is basically a set of files, but not completely set of files. When I will go like I move forward, then a slide comes where I explain Docker images. But I will give you a brief, like small introduction of images. What is Docker image? So Docker image is based on Docker files. Okay, but these images are read-only images. Okay, you can't modify it. If you have to modify it, then you have to use your container, because each container of Docker is based on their image. And in these images, not only like you see a profile image, like these images are different from that. It is a set of files and read-only files. And here the image is divided into FS layers, like file system layers. Inside image, not only a single propagation, a single protocol, but here also a like FS layers are divided. Something like if I want to explain in a particular image in a set of files, like WordPress and PHP, those two softwares like are installed. So if you convert into the Docker image, then two layers are created, and in the first layer a PHP is there, and in the second layer WordPress is there. Like suppose if I want to use only particular section of that image, then I take that image only particular section. I don't use the WordPress. Okay, so doesn't very much. I explain the images concept in detail also in my video. If you want in detail, then go with the video. Okay. Otherwise, like in the next slide, I will also cover it. So Docker Hub, like if you actually you not if you not go with move with me on Git, then this Docker Hub portion little problematic to you, because like Git to GitHub and like Docker to Docker Hub, this paradigm is same. Like Git, where you can store your repository, your local repository. Git is used to store local repository, but GitHub is a public repository where you post your repository. Repository is nothing but your module, your folder, in the simple words. Okay, so here Docker Hub, like my containers and my images, like my custom images which I created on my desktop, which is used in my containers. If I want like that, these images are also to use useful for others. So just I post this image into the Docker Hub. So basically, hub like Docker Hub and GitHub, these are the public portions. Docker Hub, we also call that is the Docker registry part. Okay, so we store our Docker repository into the Docker registry. That is the Docker Hub. Okay, we can also create images using Docker files. I tell you that what is Docker images is based on Docker files. So here Docker versus virtual machines. So here is a new concept, virtual machine. I ask you, does anyone of you go through the concept of virtual machine? Anyone little bit know about the virtual machines? Guys, anyone know about virtual machines? Actually, this is my next slide is based on virtual machines. So doesn't worry.
No, we exactly don't know.
Okay, so I start. So okay, so Docker versus virtual machine. So Docker I explain next to virtual machine. Firstly, I explain what is virtual machine. Virtual machine is basically a virtual machine that is installed on your laptop. Like this is the HP laptop, and here a operating system that is Windows. Okay, but if you want to work on a Mac OS operating system or a Ubuntu operating system or a Linux operating system, different versions of Linux, Kali Linux, so these are called virtual machines. If like in my particular, this is a physical server and here is a host operating system that is Windows, but I want to use a Linux operating system in my laptop. Then I use particularly, give me a second. Okay, yes. So, okay. So here, okay. So here you can see basic architecture. So here is a physical server that is our physical body and hardware of my laptop. Host operating server that is a Windows, because Windows is installed Intel Core, that is the software. So hypervisor, with the help of hypervisor, we can install any of the operating system. That operating system is consist that virtual machine is consist of some operating system, like virtual machine 1 consists some operating system, virtual machine 2 consists some operating systems, and here we can install multiple operating systems like with the help of hypervisor. So here I am using VMware workstation for Windows. So here if you want to see like where your operating system, so just firstly here, this is my like Windows. Here you can clearly see this is Windows 11. But if you want to like use Ubuntu, then you see it here. This is also a Ubuntu where I'm using. Like if I have to work in Ubuntu, then I also work in Ubuntu. A basic interface. I doesn't have problem with working on this. Okay. So if you want to work, then work with this. Okay. So just give me a second. I think, give me a second. Okay. So just off it from here. Am I audible? Screen is visible to all?
Yes, yes.
Yes, yes.
So here you can see, this is the symbol like VMware workstation. Here, if I click here, so here you can see a Kali Linux is installed and Windows is installed. Ubuntu 64-bit is installed. So if I want to use, then play virtual machine. So if I want to like, I want to use a Mac operating system on my laptop, then I have to install the ISO file of that operating system and use the VMware workstation that has a hypervisor that provides a way to use your virtual machines like Ubuntu, Kali Linux, and all the operating systems. It provides a way where you can use these operating systems on your laptop, but not operating system. These virtual machines also consist of some files. So if I open my presentation here, so, okay. So firstly, I will cover the small portion like what is Docker Compose. With the help of Docker Compose, you can run multiple application using single command. This is the basic concept of Docker Compose. Okay. So Docker virtual machine versus Docker containers. So what is virtual machine? Actually, I provide all these presentations so you can read. And if you want to if you want to go in detail, then you go with the videos. Actually, otherwise you can ask doubt from here. So virtual machine, what? An option to create a server with another operating system which differ from your underlying operating system. I think you clearly understand whatever written in this presentation. An option to create a different server like different operating system with another operating system which different from your underlying operating system. In this underlying operating system is Windows, but I run Ubuntu, that is the part of Linux. So okay, so firstly I will mention that if the time is limit is exceeded, then you join with the same link which I provided in the group. Okay, because I doesn't provide any other link. You join with the same, and I join you on this. Okay. Also, what is the architecture of virtual machine? Virtual machine architecture contains the libraries, the binary files, and the guest operating system, and some application which are running in the virtual machine. Suppose I am opening Ubuntu, and there I have deployed some application. So these are the applications, and binary files are also associated with it. Libraries, guest operating system also associated with it. Similarly, we can clear a multiple like 20 to 30 virtual machines, and you think that how these virtual machines are working, like how they get their resources. So they get their resources with my physical server. I allocate a 20 GB of disk space